Hey, what's going on everyone? This is Big Brace. My name is Amir. Thank you so much for tuning in. In this video, I'm going to show you how to create a weather application in a CLI style using Rust programming language. So this is the application. It says here, welcome to weather station. Please enter the name of the city. Let's enter, for instance, Paris. Please enter the country code. So US for United States. So let's say FR, which stands for France. And there we go, weather in Paris, overcast, clouds with a small icon. We have the temperature, humidity, pressure, wind speed. And at the bottom, it asks you, do you want to search for weather in another city? Let's, for instance, say yes. So let's say, for example, we want to see the weather in Chicago, United States, US. And there we go, weather in Chicago, overcast, clouds, minus 3.8, humidity, 54%, pressure, wind speed. And if you want to shut the application, simply you will type no, you will hit enter. Thank you for using our software. And before we start coding, if you're new to the channel, thank you so much for tuning in. Please don't forget to subscribe, hit that notification bell to get notifications for future videos. And if you are already subscribed to the channel, thank you so much in advance for liking the video, asking your questions, comment. This actually helps the channel to grow bigger and bigger. Thank you so much, guys, one more time. And with that being said, let's go ahead and start coding. Alright guys, so the first thing that I want to do is I want to go to a folder where I want to create my project. So I'm going to go to my folder here, Amir_code, and then I'm going to create a folder. I'm going to call it weather_rust. Let's cd to that. And let me create a new project here. So I'll do cargo new weather. Alright. And let's go ahead and open that with Visual Studio Code. All right, and we have our main.rust. We have the cargo.toml. So in cargo.toml, I will need three different dependencies here. The first one is called serd, S-E-R-D-E, right? Serd or serd, I don't know. Serd here is a crate which is mainly used for serialization and deserialization. I will need to specify the version. So we have version which is equal to 1.0. All right. And also I need in features, and the feature here is called derive. Okay. Derive is a feature that enables the use of the certain macro to serialize and deserialize. We're going to see that later in when we're going to code in main.rs. The second dependency is a request. So this request crate, it's an HTTP client library for Rust simply. And also I will need version and features. And if I'm going to talk about the features, the blocking and the JSON, simply blocking, this actually enables synchronous API support in this request. And without it, basically the request is going to operate in an asynchronous mode by default, and we need it to be synchronous. Also for JSON, this includes the support for the JSON serialization and deserialization in request. Next, I need the serd JSON, so maybe I can do like that, serd_JSON, and this is going to be version 1.0. Finally, I need colored equal to 2.0. Oops, 2.0. So serd JSON, this is part of the serd ecosystem, and the colored, this crate actually is used for colorizing the internal output in any Rust program. All right, so these are the dependencies that we need. Let's just shut that. Let's open main.rs and just delete all of that. So the first thing that I want to do is to import the standard input-output libraries. Use standard input-output. So that's the first one. Also, I will need the serd. Use serd deserialize. All right. And I'm going to use the colored crate as well. And I'm going to import everything. Now let's go ahead and create together a struct to deserialize the JSON response from the OpenWeatherMap API, right? I'm pretty sure you know what is OpenWeatherMap. I have used it a million times. So OpenWeatherMap right? So that's the one. You will sign in, you will have your API, and we're going to use it. If you don't know anything about OpenWeatherMap API, I'm going to leave a couple of tutorials in the description section below. You can check them out. And there you will see how I've created an account, I've used the API, I've used different attributes here provided by OpenWeatherMap API. All right, but for now, let's go ahead and create that that struct, deserialize, yep, and debug. So that's weather response. This is a struct. The struct is like a class, by the way. So here I will need the weather, and that's going to contain all of the weather information. So vec weather, right? So that's for the weather information. Main is set to main. That's going to contain the main weather parameters. Also the wind, feel free to add whatever you want, by the way. So this is going to contain obviously the wind information, and finally it's going to be string that's going to contain the name of the queried location where you want to check out the weather, right? So that's it for this struct. Now let's go ahead and create a struct to represent the weather description. So again, I will do derive here, deserialize, and also debug. I'm going to create a struct called weather, and that's going to hold only the textual weather description. So description to be a string. Next, I want a struct to represent the main weather parameters. So let's do derive, deserialize, and debug. Again, struct. In this case, I'm gonna call it main. Let's do like that. All right, so this one is going to hold the temperature in degrees Celsius. So F64, the humidity, F64, and the pressure, F64. All right, so the pressure is going to be represented in atmospheric pressure in HPA. Okay, and for that we'll need the F64. So the F64 is a 64-bit floating point type. That's specifically the binary 64 type defined in the IEEE 754/2008. And this type is very similar to F32. So one is 64-bit, one is 32-bit. It's as simple as that. So F64 to hold more bits. Okay, it's a 64-bit. Let's go ahead now and create another struct to represent the wind information. So again, derive, deserialize, and debug. And in this case, I need the speed, also F64. Oops. All right, and that's it. We are done with our structs. So we have one for the JSON response deserialization from the API, one for the weather description, one for the main weather parameters, one for the wind information. Now what I want to do is to create a function to get the weather information from our API. To do that, I'm going to just let me add this comment, function to get the weather information from the OpenWeatherMap API. All right, so to do that, I'm going to create this function. I'm going to call it get_weather_info. Right? And we'll need different parameters. The first one is city. It's a string. Also the country, the country underscore code. That's going also to be a stir. I need the API key. All right. And then the result is going to give us one of two options, whether it's okay, whether it's success, or whether it's failure. In case of success, we're going to just fetch everything from the API. In case of failure, we're going to just display an error message. All right, so let's do that. In case of success, we will need the weather response, this struct. And in case of failure, the request here, the request is going to result in an error. And now I want to construct the URL for the API request. So let me create this variable URL, and this URL is of type string, and it's going to be formatted this way. So as I told you, this is my API key. As you can see here that I am indeed signed in. I have my API key. It's an active, you can generate it. Okay, just don't forget to use your own API key. And then you will go to API and go to current weather data, the API doc, and you will find here, this is the URL that we need, right? Open API, let me just make it, just zoom a little bit to show you. You can see here, https://api.openweathermap.org, data 2.5, that's the version, and then the parameters that you want. All right, here are the documentation. This is the JSON format, the response, what we need to fetch actually. You can see here that the description, for example, the main, right? You can get the longitude, the latitude, okay, clouds, wind speed, right? So feel free to play with all of that, right? You can fetch anything that you want. Okay, so that's the main URL. So api.openweathermap.org, data 2.5, weather, then the query, whatever you're looking for. And then the units here are metric, and then the app ID. Okay, we need 3 more parameters. So we will need the city, we will need the country code, and we will need the API key. Next that I want to do is I want to send a GET request to the API endpoint. This GET request, by the way, is going to be blocking, and I will explain to you that in a moment. But for now, let me just declare a variable. I'm going to call it response. So this response is going to be equal to our request library, and that's going to be, as I told you, blocking, right? And the method that we want is get request, and we want to get from the URL that we have created here. And I forgot the interrogation part. This interrogation, or this question mark, by the way, in Rust in general is called the try operator. So this question mark is used for the error handling in Rust in general in order to propagate errors up the call stack. Okay, I just forgot that. All right, so this is our response. So let me talk a little bit about blocking in a nutshell. Blocking typically refers to synchronous or blocking input-output operations, I/O operations. And when you see the blocking coming after the request, this simply means that this get function from the request library is being used in blocking mode. Okay, that simply implies that the current thread is going to be blocked until your HTTP GET request completes and the response is received from the OpenAPI, OpenWeatherMap API. A quick note, do not mistakenly think that the request is synchronous library, okay? It's an asynchronous API for non-blocking I/O operations. Then next, I want to parse the JSON response because we will receive the response in JSON format. Okay, so we will need to parse the JSON response into weather response struct. So let me just declare this response underscore JSON, and that's going to be the weather response here, and that's going to be simply equal to response.json, then open close brackets, then I'm going to pass here weather response, and do not forget also the question mark. So here we are using the JSON method provided by our response object returned by the request blocking get, the first line, the response. All right, simply what we need now is to return the deserialized response. So I'm going to use the OK function or method. I'm going to pass inside the response underscore JSON. All right, cool. Hope everything is clear for you guys till now. This function is very important. Simply, it's a function to get everything from the weather API, but we haven't displayed them yet. To display everything, we're going to create this function now to display, if I can type today, the weather information. Okay, this function is going to take input response, determine that to be the weather response. So weather response. Now we want to extract the weather information from the response. So to do that, we're going to extract the weather information from the response. Okay, cool. Now let's declare different variables. The first one is description. It's going to be string. And now let me show you an example of the response. So for the description, I will need the response.weather, the weather, and this weather actually has this array, and in that array we have this object. So the object is considered to be the first element and the only element actually inside that weather's array. We're going to say and response dot weather sub 0 dot description, and we will need also a few. So we need for the temperature, I will need also for the humidity, for temperature we'll need to do it differently. So it's going to be the response without the ampersand dot main dot temp, the exact same thing is going to go for the humidity, so you just delete that. We are done with displaying. Now we want to format everything. So I'm going to declare this variable weather underscore text, and that's going to be of type string. By the way, I haven't changed the data types here. So this is F64. So we're going to format everything, weather in, and that's going to be actually the response name. The second and the third placeholders are going to be respectively the description and the temperature emoji. I will do like that. You can format it as you want. Temperature going to be in degrees Celsius. Next, I want the humidity. This is measured by percentage. The pressure is measured by HPA. I just do like this. Whatever HPA is going to be. And finally, the wind speed. Oops, I forgot all that here. I'm sorry. Just doing that, colon 0.1 miles per second. So that's basically it. So I need the response dot name. I want the description here. I want the emoji. So this is, I haven't created this function yet. We're going to create later. This is a function to get temp emoji. For now, we will leave it empty. Also, I need the temperature. I need the humidity. Oops. I need the pressure and the wind speed. All right, guys, so that's it. Let me go ahead and create this function real quick. Here is function to get emoji based on temperature. It's going to be if-else statement basically. So it's a simple function, get temp emoji. It's going to take naturally the temperature as an input. It's going to be of data type F64, and it's going to return a static string with the ampersand. That's a reference, ampersand single quote static, and that's a string. That means that simply this is going to live till the end of the execution of the program. Now simply I'm going to check out if temperature is less than 0.0. In this case, I want to have a snowflake. Else if temperature is more than or equal 0.0 and the temperature is less than 10.0. In this case, I want a simple cloud. Else if temperature is more than or equal to 10.0 and less than 20.0. In this case, I want to have a sunny cloud. In case that the temperature is more than or equal to 20.0, but also is less than 30 degrees, I want to have a partially cloudy emoji or icon. Else, it's going to be very hot. So now we can delete this comment and let's do get temp emoji and let's pass inside the temperature. All right, so we are done with that. Let's also do the coloring. So coloring the weather text based on weather conditions. So let me again declare this variable. I'm going to call it weather text colored. So weather text colored. That's going to be of type colored string. So colored string, and here is going to match description dot as underscore stir. And then simply we're going to find different scenarios. So in case that clear sky, so if the sky is clear, in this case I want to be bright yellow. So weather underscore text is going to be bright underscore yellow. And also I've added a few. So few clouds, scattered clouds, broken clouds going to be bright blue. Overcast clouds, mist, haze, smoke, sand, dust, fog, squalls, it's going to be dimmed. Okay. And in case of shower rain, thunderstorm, or snow, we'll have the color as bright cyan. And anything else, we're going to just have the normal color of the text. And now let's go ahead and create our main function. So the first thing, I want a welcome message. So print line. And here I'm going to have a placeholder. And here I'm going to, or the second argument, we're going to say welcome to weather station. It's like that. I've called it weather station. And that's going to be in bright yellow. Feel free to change the colors as you please. So we'll do like that. And then I want simple loop. So in that loop, I'm going to check out if the user is done using the program. So you're going to enter the city and the country, and then you'll get the results. Then you, the user, is going to be prompted with another question to ask you if you want to search for another country or if you're done with the program. Yes or no. It's a yes or no question. And that's it basically. So let's do print ln. And whatever you're going to type from city name is going to be stored in a mutable string variable, and I'm gonna call it name. Okay, so let me just declare this mutable variable called city, and we're going to initialize it with a new empty string. Okay, so simply that's going to be string and new. Then I want to read a line of text, and then we're going to store it in that city variable. So in order to do that, I'm going to use the standard input-output library, and we want to read line from that mutable variable called city. By the way, if an error occurs, we can do .expect and we can write an error message. So I can write, for example, failed to read input, something like that. Then I want to declare city to be equal to city.trim. And why is that? Simply to trim any leading or trailing white spaces from the city string using the trim method. Okay, we're going to assign the result back to the city variable. That's why I've used city here, and simply we're going to overwrite this city here, right, by trimming any trails or excess white spaces. And I forgot to mention that this is a str. It's going to be a str. And then you're going to repeat the exact same thing for the country. So this is for the city, or reading the city. And this is for reading country. Then you will get your own API key from the OpenWeatherMap API website. Then we are going to call the function to fetch the weather information from OpenWeatherMap API. So we're going again to match using the getWeatherInfo function, taking in consideration different parameters, the city, the country code, and the API key. And in case of status code 200, which means okay, that the response has been received successfully, we're going to call or display the weather information by calling the display weather info function. And in case of failure or any other error status code, we're going to use the ERR function, taking as input the error itself, so we can print the error message in case of this failure. And then finally, we're going to prompt the user by asking this question: do you want to search for weather in another city? Yes or no? And that's going to be displayed in a bright green color. And again, we're going to store your answer in this new string variable called input, and that's going to be a mutable variable. And then in the following line, we're going to read your input. The exact same thing like we have done with the city and the country. And also we're going to trim that to lowercase. So if you will type yes in uppercase or lowercase, doesn't matter, it's going to be properly read. And finally, if input is not equal to yes, we're going to just break out of the loop and saying thank you for using our software. That's it. This is our application. I think there is something wrong here in the brackets. That should be like that. That should be like that, and that should be like that. Let me just check something out very quickly. Yeah, this should be here. That's the function to display the weather info. That's correct. And I have forgotten to print the colored weather information, by the way. So let me just add that here. Print the colored weather information. And that's simple as that. We are printing the weather text colored by matching each condition or each status of the weather to the correct or the proper colored. And by the way, guys, I've added comments on each line for those of you who are interested in cloning the GitHub repo. So let me do like that. Let's open the integrated terminal and be careful. Now we are inside the weather_rust folder. So inside it, we have our project. So you will need to cd to that, right? What we have here is the cargo.toml, cargo.log, the .getignore, the target and the source folder. And inside the source folder, we have our main file, okay? But we can run that from outside of the source folder. So what you want to do is to do cargo run main.rs, and it's compiling. Everything seems to be working fine. Great stuff. So please enter the name of the city. Let's say, for instance, that I want to check out Warsaw. Please enter the country code. So US for United States. In my case, it's Poland, so it's going to be PL. Great stuff. So weather in Warsaw, broken clouds, temperature 7.9, humidity 81%, pressure, wind speed. All right, cool. Let's do yes, and let's check, for instance, New York, United States. We have 6.4. That's okay. Not very far from Warsaw. Let's check out the last one. Let's do Cairo, Egypt. And we have 25.4. That's great weather. And you can see that the emojis are changing accordingly. Do you want to search for weather in another city? Now, if we'll say no, we're going to break out of the loop and we'll have this message: thank you for using our software. Alright guys, so thank you so much for those of you who have watched the whole thing. You're actually a superstar. I appreciate it deeply. And if you have any suggestions for future videos, please let me know in the comment section below. And yeah, with that being said, thank you so much, and I will see you in the next video. Till then, stay safe and be well.